Let's talk about the race to the moon, a pioneering achievement for all mankind. Alright, here's the moon race in a nutshell. There was a competition between the Americans and Russians. Part of this was driven by new technology that needed to be developed. For both countries, their accomplishments became a source of national pride. To get to the moon, though, the race required development in stages. It started with both countries trying to get unmanned rockets into Earth's orbit. Eventually, the Russians were able to get not only Sputnik 1 and 2 into orbit, but then a manned rocket into Earth's orbit. Then it was a matter of manned flights into space. We scouted the moon first before landing there on July 20, 1969. Okay, so let's break it down a bit further. Sputnik 1, a beeping satellite the size of a beach ball, went into orbit October 4, 1957, thanks to Russia. Not long after, Sputnik 2 put Laika, a stray dog from Moscow, into space. Laika did not survive. It was never planned for Laika to survive. I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project will be more exciting or more impressive to mankind or more important, and none will be so difficult or expensive to accomplish. President John F. Kennedy, 1961. With these words, JFK committed the newly formed NASA to put American on the moon before 1970. Even though NASA is civilian controlled, it is funded by the government. However, the military maintained, and still does, its own space programs. This was all about the race, and of course the technology that a civilian controlled entity could develop to get us to the moon. In 1959, Pioneer 4 space probes were launched on Juno 2 rockets. Russia launched their Luna rocket 2 months earlier. It was the first human-made object to reach heliocentric orbit, was dubbed Artificial Planet 1, and then renamed Mekta. The Able Baker mission took its name from the 2 monkeys it put into space. Able, a 7-pound rhesus monkey, and Baker, an 11-ounce squirrel monkey, did survive, though they were reportedly not too happy. Thanks, NASA. NASA developed distinct program names for rockets and the space vehicle itself. For instance, Gemini program was boosted into space using a Titan II launch vehicle. The Apollo missions were lifted using Saturn rockets. As these missions were named and launched, we began to see the space race take shape. Yuri Gagarin circled Earth 1 time in April of 1961, and then was quickly followed by Alan Shepard's suborbital flight in May of the same year. It wasn't until a later Mercury mission that John Glenn became the first American to orbit Earth. During the Gemini program, American astronauts began testing newly developed equipment, putting their lives on the line to do very risky maneuvers, like spacewalks, just to test the new extravehicular activity or EVA spacesuits. These tasks helped them prepare for their trips to the moon with the Apollo program. We had to learn more about the moon before we could touch down on it. We developed Ranger and Lunar Orbiter programs from 61 to 67. So we could see the moon up close and figure out where to land. Our Surveyor program from 66 to 68 allowed us to gather moon samples so we could test them back on Earth. We simply didn't know what we might find. Even though these manned and unmanned missions were extremely dangerous, and there were some very close calls, it wasn't in space that we lost an astronaut. And to this day, NASA astronauts have only died in atmosphere, Challenger and Discovery shuttle missions included. The first program-related death was of 3 astronauts during a test of the Apollo 1 command module, sitting atop a Saturn rocket. They were locked in the capsule as an electrical fire broke out around them. They subsequently died of asphyxiation. Sadly, we lost some great astronauts that day. Virgil Grissom, Ed White, and Roger Chaffee perished, but from their loss we developed explosive bolts that could be activated from inside or outside the capsule that would allow for a quick escape. Although the Apollo program got off to a rocky start, it was successful. The direct scenario required the entire vehicle to land on the moon and then return to Earth as one unit. The Earth orbit rendezvous scenario required a moon landing vehicle to separate from an orbiting vehicle while orbiting the Earth. The lunar vehicle landed on the moon, then returned to rendezvous with the orbiting vehicle. Both would return to Earth. The lunar orbit rendezvous scenario required a moon landing vehicle to separate from an orbiting vehicle while orbiting the moon. The lunar vehicle landed on the moon and then returned to rendezvous with the orbiting vehicle. Both would return to Earth. This method was ultimately chosen. That's one small step for a man, one giant leap for mankind. U.S. astronaut Neil Armstrong on the moon, 1969. Many people don't realize he actually said a man and not just man. The words of Armstrong resonated out of TVs around the world and solidified the United States' claim to being the first on the moon. 5 more flights made it to the moon. Apollo 12, 14, 15, 16, and 17. Apollo 13 did orbit, but due to a spark in the oxygen mixture tank, their mission was quickly revised mid-flight, and a return trajectory brought them home safely. Although we are still the only nation to land a person on the moon, and we hope to return, we have hopes to do it more internationally. We have not been there since 1972. Here we see the lunar rover unfolding from the lunar lander. It's quite a feat to get a spacecraft all the way to the moon, especially if you have people, and especially if you have a vehicle for the astronauts to drive around on the moon. Some 240,000 miles away, we were able to make this happen. Let's talk path to the moon. Here we see the overall path that an Apollo mission would take. We launched the Saturn rocket, inserting it into a temporary orbit as it conducts the necessary maneuvers to position itself for leaving our orbit and reconfiguring the payload so it's ready for moon orbit insertion. This is what we'd refer to as a Hohmann transfer. As the spacecraft approaches the moon, the proper orbital insertion maneuvers are prepped and conducted. Once in orbit, the lunar lander separates from the command and service modules, carrying 2 of the 3 astronauts to the surface. Then, to leave, rocket thrusters launch the lander from its base, leaving it behind on the moon forever. The lander is caught by the service and command modules as they orbit the moon. Burns are initiated to leave the orbit and set a Hohmann transfer for Earth. The technology from the programs include, but are not limited to, the Apollo and Gemini programs making electrical power from hydrogen-oxygen fuel cells, astronauts using scanning telescopes and sextants to take star sights and plot the position of spacecraft. Guidance and navigation information was even transmitted to Earth-based computers to calculate course and velocity changes. This kind of technology was revolutionary at the time. After the race to the moon was over, we lost interest in going any further. We set our sights back on orbiting Earth. This was how we ended up with the development of space stations like Skylab and our awesome space truck the orbiter component of the space shuttle. Lots of experiments were being conducted. These experiments helped with the development of things like the Hubble Space Telescope, and even the need for international collaboration. The ISS is massive now, and the experiments there never stop. It's an orbiting space lab. Even our missions to Mars, especially of late, are continuing to revolutionize space travel and the technology we need to have interplanetary human travel.